10.3, Example 1. In this example, we're going to go ahead and look at how to convert polar coordinates to rectangular coordinates, and then convert rectangular coordinates back into polar units. So, here we go. The first one we're going to go ahead and look at is we start with the point 4 comma pi over 2. Now what I want to do is I want to go ahead and turn that into regular Cartesian units. So, the first thing I actually look at is I look at the second value, because that tells me how much I need to rotate. So I need to rotate pi over 2. And pi over 2 is going to take me all the way to the y-axis. So I'm going to rotate pi over 2. Then this number, 4, tells me I need to move up 4. So 1, 2, 3, 4. So I'm putting my point right here. This is the point 4 comma pi over 2. Well, if we were just to look at that and I ask, okay, where is that on the graph? It's also at the point 0 comma 4. And that's it. That's really all there is to it. If you can just look at a graph and see it, then you're done. So this is equal to 4 comma pi over 2. This is rectangular. And this is polar. Alright, the second one we're going to look at is negative 3 comma pi. So the first thing I do is I go ahead and look at the second value, which is pi. So I need to rotate pi. There we go. I rotated pi, which is 180 degrees. So theta is equal to pi. And then this number tells me negative 3. So starting at the origin, I would normally go in this direction. But now, because I'm negative, I'm going to go 1, 2, 3 in the opposite direction. So this is the coordinate negative 3 comma pi. Now if I convert that to rectangular, this is also the point 3 comma 0. So my rectangular coordinate is 3 comma 0. And my polar coordinate is negative 3 comma pi. Alright, let's do another one. So now I'm going to have 16 comma 5 pi over 6. So step 1 is I'm going to rotate 5 pi over 6. So 5 pi over 6 will take me about to here. 5 pi over 6. And then I need to go, I'm going to draw a little line real quick. And I'm going to go 16 units. Now the deal here is I'm going 16 units on this line. I'm going 16 units this way. So I'm going to say that's this point right here. 16 is not my coordinate, but it's the distance, it's the hypotenuse of this triangle. So then what I'm going to do is I'm going to erase that. And then I'm going to draw my triangle. So I go straight down and across. So I need to find this distance and I need to find this distance. This is my y and this is my x, because in order to find rectangular coordinates I need it in x and y. So just remember, all this is a triangle. So to find the x coordinate of a triangle, it's r cosine theta. So this is going to be 16 cosine 5 pi over 6, which becomes 16 cosine 5 pi over 6 is negative radical 3 over 2. So it's negative 8 radical 3. So this is negative 8 radical 3. And then the y coordinate is similar, but it's r sine theta. So this is going to be 16 sine 5 pi over 6. 16 sine of 5 pi over 6 is 1/2. So y is equal to 8. And so this is 8. So that means that the coordinates here is negative 8 radical 3 comma 8. And this is equal to 16 comma 5 pi over 6, where this is my rectangular unit and this is my polar unit. These two coordinates represent the same exact point. So in general, if I want to convert polar units to rectangular units, I'm going to go ahead and use these two equations. X equals r cosine theta and y equals r sine theta. Now let's talk about how to convert rectangular units to polar units. We're going to do this in a very, very similar way. So the first thing I'm going to do is I'm going to start with my rectangular unit, where this is x and this is y. So I plot the point 1 comma 0, and now I need to identify, remember when I want polar, I'm going to want r comma theta. So to find r comma theta, my r is my distance from the origin to this point. So this distance is 1. So my r is 1. And theta is the amount that I revolved up from the x-axis. Well, I didn't go any because I'm still on the x-axis, so it's either going to be 0, or I could get the coordinate 1 comma 2 pi, or 1 comma 4 pi, or 1 comma negative 2 pi, and etc. Right? As long as my revolution put me at that point, I'm all good. All right, let's talk about the next one. I've got negative 3 comma 3. So 1, 2, 3, 1, 2, 3. And I'm going to put a dot right here. So that's the coordinate negative 3 comma 3. Now, so I know that this distance is negative 3, and I know that this distance is 3. So what I'm going to go ahead and do is I'm going to draw a triangle, and this is going to be r. And then from the x-axis to here is going to be theta. So I know, using the Pythagorean theorem, that r is going to be equal to 3 comma radical 2. And you can just do the Pythagorean theorem on that. I also know that this angle here is going to be pi over 4. So this has to be 3 pi over 4, right? Because I'm at the next 45, 45, 90 triangle. And we know from trig that this theta is 3 pi over 4. So my coordinate is 3 radical 2, 3 pi over 4. So a little side note is you can always use the triangle method and use the Pythagorean theorem to find r. So in this example, we're going to go ahead and plot 0 comma negative 4. So 1, 2, 3, 4. So that goes here. And then I need to find theta. So I start at the x-axis and I rotate around, and I get theta is equal to 3 pi over 2. And r is the distance from the origin to that point. So this distance here is 4. So then what I'm going to do is my r is equal to 4, and my theta is equal to 3 pi over 2. So this just becomes 4 comma 3 pi over 2. Another way you could look at this problem is that you go up pi over 2, and then you go backwards 4. So instead of going 1, 2, 3, 4, you go backwards 4. So this is the same as negative 4 comma pi over 2, or any other combination that's going to end up getting you at this point. In general, to go from rectangular to polar, we have two equations. R equals the square root of x squared plus y squared, and theta is equal to tangent inverse of y over x. These two equations will work every time when you're given a x and y coordinate.